Hi everyone, I'm Cheryl. In this problem, we're asked to find three things: the moment about the x-axis, the moment about the y-axis, and also the center of mass. For a lamina that has uniform density and is bounded by y equals 1/2 x equals 2, and y equals 0. Now, we know that the moment is the mass times the distance. But in this problem, because I have a lamina, I don't have a mass point. So I'm going to make use of the fact that the mass can also be thought of as the density times the area. So let's begin by finding the total mass of this lamina. Right? So the density is uniform, so I'm just going to use a rho to represent the density. The area, I can use calculus to find the area of this lamina by taking the integral from 0 to 2 of my top function minus my bottom function. However, as I'm looking at this, that might be a little bit overkill in this problem because my lamina is a triangle and I have a geometry formula for that. So I'm going to make use of my geometry formula. And I know that the area of a triangle is 1/2 the base, which is 2, times the height, which is 1, which gives me a total mass of rho. Okay, now I'm going to go ahead and get started on my moment about the x-axis. Now, I have the formula written up here for the moment, but let's make sure I understand where that formula comes from. Remember that the moment is the density times the area times the distance. Well, rho is the density, and the change between f of x and g of x dx, that's the area if I use a little representative element, because that will be the change in the height over the change in the width. This last part, I'm going to assume my density or my mass point is right in the center of this. And so if I take f of x and add g of x to it and divide by 2, I'll get the directed distance from the x-axis, which is exactly what I need to calculate the moment. So that's where that part of the formula came from. Okay, now all I have to do is plug in the specifics for my situation. So I'm going to be integrating this time. If I take my rectangles from 0 to 2, I'll have my constant density. F of x is 1/2 x. G of x is 0, so I'll add 0 and divide by 2. Then to calculate that area, I need 1/2 x minus 0 dx. With a little bit of algebra, I can reduce this down to rho times, this will be 1/4 x, and this will be 1/2 x, so that's going to be 1/8 x squared dx. Right? This is a fairly simple integral now. We're going to have rho times 1/8 and x cubed divided by 3 evaluated from 0 to 2. So I'll have rho over 8 times 2 cubed, which is 8/3. And then when I plug in the lower limit, I'm going to get 0. So I end up with rho divided by 3 for my moment about the x-axis. Now let's do the moment about the y-axis. Again, we know that the moment is the density times the area times the distance. And here's our density and our area of that representative element. Now we need the directed distance from the y-axis. So the distance from the y-axis out to my mass point. You can calculate that by using the x-coordinate. So that x value in my formula represents that distance. So now I have to plug in the specific information for my problem. So I'll be looking at the definite integral from 0 to 2. I have my uniform density. F of x is 1/2 x. G of x is 0. I'll multiply by x dx. With a little bit of algebra, I can write this as rho times 1/2 x squared dx. And now I'm ready to integrate. So I've got 1/2 rho, which is a constant that can be pulled out, and the integral of x squared dx is x cubed all over 3, and I'll evaluate that from 0 to 2. Plugging in the upper limit, I'm going to have 1/2 rho times 8/3. When I plug in the lower limit, I'm just going to get 0. So this simplifies down to 4 rho all over 3. That's my moment about the y-axis. So now I'm ready to find the center of mass. So to find my center of mass, I know I take the moment about the y-axis, which I've just calculated to be 4 rho over 3, and I divide it by the total mass, which I calculated to be rho. To get the y-coordinate, I need the moment about the x-axis, which was rho over 3. And again, dividing by the total mass of rho, which tells me that my center of mass is going to be at the point 4/3, 1/3. Now let's go back to our picture just for a second to find out where that point is. The point 4/3, 1/3. So 4/3 is 1 1/3, and 1/3 is going to be right about in here. And that's going to be my center of mass. I hope that was helpful. Thanks.